The continuation concept of Maxwell's equation of unit 5 is preceded with the Poynting theorem. As the name indicates, it has been identified by the physicist called as Poynting. His name is Poynting. So now we are just considering a closed surface which encloses a capacitor, a resistor and an inductor. So the capacitor, as we know, it is storing the electrical energy, and inductor stores the magnetic energy, and the resistor includes the ohmic losses. Everything is bounded within a volume V. It is a closed surface enclosing a volume V. It is understood. So now we define what are electromagnetic waves. When they travel from source to destination, they transfer energy. That's a known concept. However, we are going to learn the relationship between the energy transfer, electric field and the magnetic field, which in turn is defined by the Poynting theorem. By definition of Poynting theorem, the net outward power flow is exactly made equal to the time rate of decrease of energy stored in the volume V, which is minus the ohmic power dissipated. How to write it mathematically is a proof of this theorem what I have spoken over here. Generally saying it is a vector product of E and H. P is equal to E cross H is a definition of Poynting vector, which means that the electric field intensity E is defined as E along x direction, so Ex of Ax vector, and the magnetic field is defined along the y direction, so Hy of Ay vector. So the cross product of Ex of Ax vector cross Hy of Ay vector results in Pz of Az vector, which means the power is flowing along the z direction. That's what is the meaning of analysis of Poynting vector or the electromagnetic wave along the z direction. How to arrive at the condition? Let us consider the Maxwell's equation 1. We know that by Maxwell's equation 1, del cross H is equal to J plus dou D divided by dou T. I can rewrite this equation as J is equal to del cross H minus of dou D divided by dou T. However, this has an unit of ampere per meter square, current in terms of the cross-sectional area. To modify this equation, let us take the dot product of E on either side. But what is this depicting exactly? I have to modify this equation using a vector identity by a known vector identity of A dot of del cross of B. It is defined by B dot of del cross of A minus of del dot of A cross of B. So we have applied this for this term E dot of del cross of H. In the place of A, I have E vector. In the place of B, I have H vector. So I am rewriting the equation E dot of J, left hand side remains the same. H dot of del cross of E minus del dot of E cross of H is replaced for this term minus E dot of dou D by dou T. What are the known relations already? By consecutive relation, we know that D is equal to epsilon into E. Also by Maxwell's equation 2 using Faraday's law, we have arrived at del cross of E is equal to minus of dou B by dou T. Again, B is consecutive relation mu H, so the equation is rewritten as mu of dou H divided by dou T. Now take this equation, substitute back again in this equation because I have del cross of E here. So I can substitute Maxwell's equation 2 here. So E dot of J becomes equal to H dot of, this is Maxwell's equation 2, minus of mu into dou H by dou T minus del dot of E cross of H as H minus E dot of, in the place of D, it is epsilon into E. So it is epsilon dou E dot ED divided by dou T. By mathematical analysis of vector algebra, I can rewrite dou by dou T of H dot of H as half the value of dou H square divided by dou T. Similarly, E dot of dou E by dou T is rewritten as half of dou E square divided by dou T. Now based on these two equations, I am going for the substitution. So E dot J becomes equal to minus of mu by 2 dou H square divided by dou T minus del dot of E cross of H. In the place of dou E dot of E, we have epsilon by 2 dou E square divided by dou T. Now separate these two terms. So I have rewritten the equation as E dot of J equal to minus of dou by dou T in both the terms is common. So minus of dou by dou T, it is mu H square divided by 2 for this term, and is mu epsilon E square divided by 2 for this term. Minus this term remains as H, del dot of E cross of H. So now to define about the whole of the analysis, let us take the volume integration on either side. So the equation is modified as integral E dot of J of dV over the volume integration is equal to, again take the volume integration, minus of dou by dou T integral volume integral mu H square divided by 2 plus epsilon E square divided by 2 of dV minus integral del dot of E cross of H of dV. So I can replace this volume integration using surface integration using the divergence theorem. Del dot of E cross of H of dV can be written as E cross H of ds using the divergence theorem. Volume can be replaced in terms of surface using the divergence theorem. So the final equation has three terms. One is integral E dot of G of dV, which is power flow out of the volume, which is equal to rate of decrease of energy stored, this term, and this is the Poynting vector P equal to E cross H. So this gets the analysis of the Poynting vector and the Poynting theorem analysis. Thank you.